Hello and welcome to the next session on Excel for Finance. In this session, we will talk about a new concept called continuous compounding and see how the future value and present value can be computed when there is continuous compounding. Now, in the earlier session, we have seen that when frequency of compounding in a year is more than 1, we compute the future value using a formula present value into 1 plus r by m to the power of n into m, and present value by dividing future value with 1 plus r by m to the power of n into m. Here, m was defined as number of times the compounding was done in a year. Therefore, for semi-annual compounding, m was 2, and for quarterly compounding, m was 4, and so on and so forth. Now my question is, what happens when the value of m tends to infinity? That means number of compounding in a year becomes infinite. So you are almost continuously applying the compounding effect. Now this is called as continuous or infinite compounding in finance. When you have continuous compounding, or when m tends to infinity, we have a new formula for calculation of future value and present value. The future value is calculated as present value into e to the power of r into n, and present value is calculated as future value divided by e to the power of r into n, or alternatively, future value multiplied by e to the power of minus of r into n. Here, e is a mathematical constant, just like pi. The value of e is 2.71828, and so on. Just to illustrate the difference between simple interest, compound interest, and continuous compounding, you can just look at the graph which is given here. The blue line represents simple interest. That means same interest is paid every year. In that case, the growth of your investment or value of your investment will be linear in nature. The moment you move from simple interest to compound interest, where you start getting interest on interest, the growth curve now moves from linear to slightly curvilinear, which is represented by the red line here. When you move from compound interest, which is non-continuous, to a continuously compounded interest, your growth line becomes little more curvy in nature, which is represented by dotted green line, which means as the number of years increases, the difference between simple interest, compound interest, and continuous compounding keeps growing. The concept of continuous compounding has wide applications in finance, especially while dealing with financial markets. Now, why is that so? Because the asset prices, especially for those assets which has a secondary market where it is traded, the prices of the assets keep changing almost instantaneously. For example, take the case of price of a share. The share price of a company when trading is going on keeps changing almost every second. So while evaluating or analyzing such financial markets, we normally use continuously compounded rates of returns. Now let us see how we can use MS Excel for computing the future value and present value with continuous compounding. Let us take an example. Let us assume that the rate of return on a share is 15% per annum compounded continuously. Let us assume the company is not going to pay any dividend during the next 3 years. If that is the case, what will be the price of the share 3 years from now if the share is currently available for rupees 1,250? Let's go to an Excel file and see how this can be calculated. Okay, so here is the Excel file where I have represented the same example. Price of the share today, which is present value, is rupees 1,250. Continuously compounded rate of return R is 15%, and number of years N is 3. Now, for the exponential function E, Excel has a function called EXP. We are going to use that. So remember, our formula is future value is equal to present value into e to the power of r into n. Instead of e, Excel has a function called EXP. Therefore, future value is equal to present value multiplied by EXP. Remember, EXP is equivalent to the exponential value or E. Now bracket open, R 15% multiplied by number of years N, bracket close. I will press enter, I'll get the value now. So I'm telling once again, present value multiplied by EXP within bracket R into N. So future value will be equal to 1960.39. Now using the same example, let us work backwards and see how to calculate present value. So for present value, we will use future value multiplied by e to the power of minus of r into n. Let's do that. Here future value is 1960.39 multiplied by exp bracket open minus one more bracket 15% r multiplied by number of years n bracket close, the first bracket also close. So exp to the power of minus of r into n, say I'm back to 1250. So there is no other direct formula like FV or PV in Excel. Here we have to use the formula equation itself. Unlike in other cases, we have seen there is an FV function, there is a PV function. Here your FV and PV function will not work. We have to type the formula, which is PV into exp to the power of r into n for future value, and future value into exp to the power of minus of r into n for calculation of present value. Okay, so here I have given it again. Future value is equal to present value into exp to the power of r into n, and present value is equal to future value into exp to the power of minus r into n. Actually, this concept of continuous compounding can be compared and understood with other types of compounding in a very interesting manner, and I'll do that in one of the videos in future. I hope you understood the concept of continuous compounding and enjoyed watching this video. Thank you very much for watching.